Okay. Hello, we are going to start this lesson on mathematical geography and looking at some of the astronomical units of measure. We were talking before about units of measure for small things. Okay, now we are going to talk about some of the ways that astronomers use units of measure for measures for large things. All right, so the first unit of measure that astronomers devised, one of the first actually, was the astronomical unit, and that is defined basically as the average distance from the Earth to the Sun. Okay, and so that is defined as 1 astronomical unit. There were, actually this unit was of an unknown quantity for a long time. People knew that there was a distance between the Earth and the Sun, but they didn't know exactly how long that distance was. And there's a fascinating story about how they were able to find out, like how many kilometers really there are between in 1 astronomical unit. Okay, so but the astronomical unit is very useful for measuring things within the solar system. So for example, astronomers knew the planet Venus is around 0.7 astronomical units. So it's a little closer to the Sun than the Earth. All right. The planet Mercury is 0.39 astronomical units from the Sun, so quite much closer to the Sun than the Earth. And Mars is about 1.52 astronomical units. Okay, so Mars is farther in its orbit from the Earth. So astronomical units is actually very useful as a unit of measure for measuring things within the solar system. For things that are far away from the solar system, for stars, okay, what astronomers use is a unit called the parsec. And the parsec uses the parallax method to being able to show where the star is, how far the star is. The way that it works is that astronomers measure the angle or the position of a distant star against the background of much farther distant stars. Okay, so here it shows Ursa Major, all right, and another star that is closer. And so we see that at one point of the year, when the Earth is at this point in the orbit, the star that we are looking at looks to be in this position. Okay, looks to be kind of between the leading edge, within the deeper part of Ursa Major, or the Big Dipper. All right. Now, 6 months after, as the Earth goes around the Sun in its orbit, astronomers look at that same star again and measure the position of that star against the background of the other stars, and they see that now that star appears to be in a different position. Of course, the star has not moved. What it has moved is actually the Earth and the angle at which we can see the Earth, the star. And so that is the parallax effect. All right, so the parallax effect is the effect that you see things moving when you change your point of view, your perspective point of view. The object is not moved. What you are seeing is the angle of perspective. And so astronomers measure the angle here of parallax, and then they are able, through trigonometry, to measure the distance between the Sun and the star. Okay, so if this angle is 1 arc second, okay, so that would be 1 degree of an angle has 60 minutes. Each minute has 60 seconds. This is not a measure of time. This is a measure of angles. So if it's a really, really small angle, just 1 second, then the distance for a 1 second parallax is 1 parsec. That is the definition, okay? So let's look at another graphic of the same effect, all right? And so you can see here where the parallax angle is being measured, all right? So if this angle is 1 second, then this distance, the distance between the Earth and the star, is 1 parsec, okay? So 1 parsec is about 206,265 astronomical units. Remember, that 1 astronomical unit is the distance between the Earth and the Sun, okay? So the parsec is enormously much bigger than the astronomical unit. That is why the parsec is used for measuring distance to the stars, okay? The nearest known star to the Earth, other than the Sun, is called Proxima Centauri, and it is 1.3 parsecs away, all right? So can you see that the parsec is a lot easier to use as a measure of distance than the astronomical unit, okay? Here we would have to say, oh, it is 260-something thousand astronomical units away. So instead of using the astronomical unit, when we talk about distance to stars, okay, to relatively close stars, we use parsecs instead of astronomical units. So you see there another example of how the unit of measure changes depending on what is it that we are trying to measure. A third astronomical unit is the light year. This is a measure of distance, not of time. Even though it has the word year there, it is really a measure of distance, not of time. A light year is the distance that light travels in a vacuum in 1 Julian year. That is the official definition of the light year. So light, of course, travels a slightly different distance if it's not in a vacuum, but most of space is in a vacuum. So that is actually very good because that basically ensures that the light that we see from the stars is traveling at the speed of light. And so however long it takes for that light to reach the Earth, that can be measured, and however many years it takes for that light to reach the Earth, then we have to say that that star or that source of light is so many light years away, okay? 1 parsec, how we defined it before, 1 parsec is 3.26 light years, all right? Light years, because it's such a large astronomical unit, is very useful to measure the distances between distant stars, galaxies, and clusters of galaxies. All right. What happens with the parsec, one of the problems of the parsec is that the more distance that the object is, the smaller that the angle, the parallax angle is. So imagine if the star that we are talking about were even further, okay, from the Sun, then the angle would be actually a lot smaller. And so sometimes things get so far away that the angles are extremely difficult to measure. And so the parsec becomes not very accurate or very useful or easy to measure. So then we use the light year as the unit of measure. Okay, so I hope that this helps and that this answers some questions about astronomical units. If you have any questions, of course, feel free to ask. Thank you.